So another student sent in a question this morning, and it deals with slope and has multiple parts to it. So I'm going to start at the first. The student was saying she was good with this question right here of determine what can be gathered from the table. So you might want to hit pause if this is your first time to see this problem in the homework, and you might go ahead and read through what's going on here. And I agree. The looper has more writers per hour than the screamer. So that's the correct choice. But then it keeps going and asks several other things. So I'm going to go right here. It says the looper dispatches trains every 1.5 minutes, and that's how many seconds. Calculate, so in the end, we want to know the number of riders per train. So this is dimensional analysis. And this is where we're going to have to, I already worked, I don't want to show you all of that because I wrote some more stuff on there for the other questions. So I'll go ahead and work on this one. So right here, I'm going to take what I know and try to get it back to the end of I want riders per train. So practicing dimensional analysis, in the end, I want riders per train. That's where I need to make it, train. And so here, I know something. I know this 960. So I know the 960 is the number of riders per hour. Now that's awesome to start with, but I need, oh goodness, I need riders in the numerator. So this one's staying. I don't want that one to move. I don't want it to go away. I got part of it right. But I need train. I don't need hours, so I got to do some work to get rid of that hour and end up with train in this. And so I'm going to go here and notice that the trains dispatch every 1.5 minutes, or that's seconds. Well, I'm going to go with the minutes one. And so since I'm going to need minutes, I'm going to go ahead and work on this hour, because I know that 1 hour is worth 60 minutes. My hours go away, and that gives me another number. So riders per minute, nope. I need riders per train. And so this was just a nice conversion to be able to get me out of hours, and I'm now into minutes, and look what we've got here. It dispatches trains every 1.5 minutes. So it's 1.5 minutes for every train to get dispatched. My minutes go away, and looky, looky, looky. In the denominator, I've got train. So now I need to multiply everything in the numerator together and then divide it by everything in the denominator. So remember, when you get your calculator, hit clear a bunch of times. I'm going to do 960 times, don't have to worry about the 1, times 1.5, and I'm going to hit equals. And then I need to divide by whatever's in the denominator, 60. And when I do, I get that there are 24 riders per train. And that's where the student's question initially started. Because when she sent it to me on Ask My Instructor, it was telling her it's 24, and she's like, how in the world? So this is a good place to stop the video. Think on this and even practice setting it up by yourself without looking at the video or your notes. But there were more pieces, and I wanted to keep going. This was her question, but I want to keep going because then it starts talking about a table. And it's a table for the looper. And so it talks about number of trains and the number of riders. Number of trains, number of riders. And it's even going to tell me that X is the number of trains. So when you're dealing with problems that are having two variables, I like to see a graph. And so it says X would be my number of trains and Y would be the number of riders. So this is the number of trains, like 1 train, 2 trains, 3 trains, etc. And then the number of riders. And so I need to know, for 1 train, what do I have? Well, I just found out for 1 train I have 24. So watch me be lazy and put that one at 24. So right here, 1 train, I got me 24. 2 trains, well, 2 trains would be 24 on the first train and 24 on the second train. So I'd just like to get my brain wrapped around what in the world is going on. And 2 trains would be 48. So look here. For 1 train, I've got 24 riders. For 2 trains, I've got 48 riders. And what I like to do in my calculator, when I see what's going on here, If I had 24 on the first train, I need to add 24 for a second train. I'm going to leave that on my calculator, add 24 again. I get 72, and et cetera, et cetera, et cetera. I guess I'll go ahead and keep going. I'm going to add 24. I get 96. Add 24. I get 120. If I wanted to check this real fast in case I might have gotten off, 5 trains times 24 people. 5 trains times 24 people is 120. Great place to be right now. I'm going to add 24, and I get 144. Add 24, 168. And add 24, 192. And I'm just going to go ahead and double check my last one. Because if I have 8 trains, and I got 24 people on each train, 8 times 24 better be 192, and it is. So this is another part of the question. Again, the student was only asking about how to get that 24, but I want to keep going. This is a really good one that you can see on the test, which opens tomorrow. And so you answered 50. I don't know what that was. Oh, that's talking to, I don't know what that's talking to. Maybe that was talking to the student about the 24. I don't know. But I do know there were more questions. One said, can you do the slope in words? And let me look at my notes to see if I see more here. No, I didn't do any more. Oh, I think it was a drop-down menu. And so it says, and it's talking about a rate of change, what's happening each time. Like I go over one train, I go up how much. I go over to a second train, I go up how much. So at 0 trains, we had 0 riders. So I go over, add a train, it's 24. Add another train, 48. Add another, oh, that doesn't go there. Add another train, and it says 3 would be 72. So that would be here. We've got us a linear equation going. And so with that in mind, what is our constant rate of change? Well, it's going to be for every, well, and it can go one way or the other. The same student was asking me about slope. And so slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or if you're dealing with word problems, sometimes it's just staring you in the face. Y is the total number of riders. My riders are in the numerator, just like my y's are in the numerator here. The number of trains, that's my x, and so it's going to be y over x, and that's another definition of slope. It's the change in y over the change in x. And in our case, when you get to this question, it's going to ask you for a number, and then you've got a drop-down choice. You'll either put riders or trains in the numerator. Well, remember the y goes in the numerator, so it'll be 24 riders over, remember x goes in the denominator. And in this problem, our x, that's the number of trains, even on our graph, it's the number of trains. So it's 24 riders per train, or I even like to write per one train, but I don't think you have a drop down for a number there. So you'll just have to put 24 riders per train. It continues to go on and says, hey, do a graph. And I'm like, ha ha, we've already done it. And so a graph is going to have trains for the x, because that's your x, number of trains. Y would be the riders. So at 1, we're at 24, 2, we're at 48, 3, and when you look at the choices, you will see obviously which one of those is the correct graph. So this is playing around with linear equations, some slope, a table, kind of some formula, and definitely graph.